हरि करना।
So we have seen statistical significance, p-value, type 1 error, type 2 and alpha. So you may question, so why do we need to learn all those things? Do as a data scientist, do we do anything with that? Will that learning p-value, alpha, type 1, type 2 errors, will it help us? Of course it does. So that's the reason I'm teaching you, or else I would not have touched it. So where will it be helpful for you? That I'm going to tell you in this slide. So the work that data scientists do is typically not destined for publication in a scientific journals. So the debate over the value of a p-value is somewhat academic. For a data scientist, a p-value is useful metric in situations where you want to know whether a model result that appears interesting and useful is within the range of normal chance variability or not. So as a decision tool in an experiment, a p-value should not be considered controlling. So but merely another point of confirmation and another point of confirmation and information bearing on a decision. For example, so p-values are sometimes used as intermediate inputs, and in some statistical or machine learning models, a feature might be included in or excluded from a model depending on its p-value. So if I put it in simplest way, the above statement highlights that for data scientists, p-values are useful metric in determining whether a model result that appears interesting and useful is within the range of normal chance variability. So this means that p-values can help data scientists assess the statistical significance of their findings and determine whether their models are providing meaningful insights or merely the results of chance. However, it's important to note that p-values should not be used as the sole criterion for making decisions. Rather, they should be used as one of many pieces of information that data scientists take into account when making decisions. For example, if a model result has a low p-value indicating statistical significance, it might be more likely to be included in a statistical or machine learning model. On the other hand, if a result has a high p-value indicating that it's likely due to chance, it might be excluded from the model. So like this, you can use p-value and statistical significance in as for data science modeling. So if a model result has a low p-value, so indicating statistical significance, it might be more likely to be included in statistical or machine learning model as a feature. If it has a high p-value, we may not. So overall, the p-value of the p-values to data scientists lie in their ability to help make informed decisions and determine whether their findings are meaningful or simply the result of chance. So now let's take a simple example to understand this better. So p-values for data scientists. So suppose a data scientist is building a linear regression model. So a linear regression model to predict house prices based on various features, such as, let me write down. The first feature is square footage, square footage. Second feature is number of bedrooms, number of bedrooms, number of bedrooms. And the third feature is location. And one of the feature being considered also as the presence of swimming pool. Another one is presence of swimming pool. So these are the features to predict the house price. So our dependent variable or response or target is equal to house prices. House prices. And our independent variables or predictors or features are the following. Okay, so the data scientist collects data on 100 houses, half of which have a swimming pool and half of which do not. Okay, the first uh, the first activity has done the data set. So case 1, data set with 100 houses, 100 houses data records. Okay, so out of that 50 have swimming pools and 50 do not have swimming pools. So now in this case, after running the regression analysis for this, a regression analysis for this case, the data scientist calculate the p-value. The data scientist calculated the p-value. So p-value he got is 0.02, indicating that statistical significance at the 0.05 level. So this is indicating the statistical significance level at 0.05. So this means that there is a significant association between the presence of a swimming pool and house prices, and the swimming pool feature is more likely to be included in the feature in the model. That's what the conclusion from this conclusion for case 1. So case 1 conclusion is, so there is a significant association between the presence of pool, that's a swimming pool, and house prices. So, and that's the reason, as the association is significant. So what, as a data scientist, what I'm gonna do is swimming pool feature is more likely to be included in the model. That's it. That's where the p-value is used by the data scientist. On the other hand, if you take the case 2, where the data set, the data scientist collects data on 100 houses, same data set is equals to 100 records, but this time 10 of them having a swimming pool, 10 have a swimming pool, 10 have a pool, and others do not, rest do not. So now After running the regression analysis, the data scientist calculates the p-value for the swimming pool, and he finds that p-value is equals to 0.25. Obviously, it's not lesser than the 0.05, so it's greater than 0.05. Hence, it indicates that there is no significant association. Just a minute. Let me copy this. Okay, slowed down. Yeah, finally. It's taking some time. So there is a no. I don't know. It's responding very badly. There is no significance association between the presence of pool and house prices. Hence, the data scientist might decide to exclude. Okay, there is something wrong. Okay, I don't know. Let's leave it. There is. I'll just no tell you. There is. Uh, the data scientist might decide to exclude the swimming pool feature from the model since it's not providing meaningful insights. So in both cases, the p values serves as the intermediate input that helps the data scientist make informed decisions about which features to include in the model.